All right, in this lesson right here, what we're going to do is take a look at control statements and how we can use them to affect the execution order of our statements inside an application. Now, if you think about it, all the way up to this point, our programs have been nothing more than just linear statements that have been executed inside our main function, right?
Right.
I mean, we've had inside main, we've got one line, which has been like, declare a variable, put some stuff in it. Another line, declare a variable, put some stuff in it. Then let's print that stuff out. Then let's print some more stuff out. And Joel will be like, woohoo, we got a great program, right?
Right.
Well, now it's time to take a look at how we can take our application and make it a little more intelligent. Make it make some decisions on its own. And that's where things start to become very powerful and also gives us a great deal of flexibility. So this lesson here is actually the first of two lessons where we're going to be looking at control statements. And in this lesson, we'll be looking at the if statement, we'll be looking at switches, we'll be looking at goto, etc. So with that, Joel, let me go ahead and hand it over to you.
All right, so the first thing we're going to do is create a variable, because variables are cool. So we'll create an integer named x, and we'll assign it the value 2 or 3. And we'll end that with a semicolon, and then we'll actually define our if statement. And so let's say if x is greater than, say, 2. Okay, now what I've just done is say this if statement basically starts out with just a simple if, and then it starts with a parentheses here, and these parentheses, inside of them, we're going to define the basically an expression that if it's true, it will get inside and actually do something.
Right.
So if I said if x is greater than 2, then go inside these two curly braces, okay? And I can say cout x is greater than 2, okay? And then we can say, basically, end L. And this, basically, this evaluates to true. This expression is going to, the if statement is going to say this value is true if it's something other than 0.
Right.
So if it's greater, if it's 1, it's going to be considered true. If it's negative 2, it's going to be considered true.
True.
If it's 0, then it's false.
But as we've already seen from the operators lesson, basically what's going to happen here is a 1 is going to be returned back here. What Joe's pointing out is just if we wanted to, we could come in here and put negative 5 or... Well,
right, I could even put in here, say, I'll just put in 1.
Right.
That means that if I run this, so let's control F5.
It's always going to be true.
It's always... x is greater than 2. So it's always going to go inside our if statement.
So, yeah.
If I put in, say, 0, however, this is going to obviously not go
print
inside
out
the if
anything.
statement.
So it might be a good idea, as opposed to outputting x is greater than 2, just output something like statement is true, or expression is true, something like that.
Statement is true.
Okay, statement is true.
So, I mean, we could go into here and say negative 2, and even negative 2, if we run this, statement is considered
That's right, because
true,
it's something other than 0.
Right. So if we go in here, we can say, put our x is greater than 2 back in here.
Okay.
Now that introduces another thing, the else statement.
All right.
So if we put an else, you'll notice that it bolds the connecting if statement. So with an if, there has to be an adjoining if statement, if you will. So there has
you mean with an else?
With an else.
Right.
So to have an else, you have to have an if.
That's right.
So again, we can just put curly braces to define the inside of, basically, if this statement isn't true, then it goes inside the else.
Right.
So inside here we can say statement is false, and we can end L. So if we run this, we're going to get x is greater than 2, so statement is true. If we change x and say it equals to 1, this statement is going to evaluate to false, so we're going to jump into our statement is false section. Just so you can see this a little more clearly, let's go ahead and jump in here and put a breakpoint right there, press F5. Now we're back into debugging mode. And if we press F10 to walk through our code, press F10, x is set to 1. If x is greater than 2, x, as you see down here, is 1, so that's not greater than 2. So we're going to go into our false statement
That's
here.
right, and watch the yellow arrow there showing where the next line is going to be
executed. The next line is here. Another thing we could do is just go back up here and drag him up, and then if we change this value down here to, say, 3, now we've just changed the value of x to 3. So 3 is now... this statement is now going to be evaluated to true.
Right.
So if we press F10, we now go back into our statement is true.
Right.
So that kind of shows that. Now let's stop debugging here. And another thing we can show is else if. Now else is very similar. I mean, else if is very similar to else, basically. All it is appending an if to it.
Right.
So we can say here, else if x equals 1, then we go into here. So if x is greater than 2, so anything that's greater than 2 will be evaluated to true.
Right.
Otherwise, else if, we just put an else followed by a space and then the if statement again, so that it evaluates this next expression which says, is x equal 1. Is
Right.
x equal to 1? So then we can say in here, x equals 1. Excuse me. Let's say end L. And then you'll notice that we have statement is false in the very bottom, our last else statement.
Right.
And we can say inside else. Okay?
Okay.
So if we run this, you'll notice that x, if you look up here, x is equal to 1, so we get into the expression x equals 1.
Right.
So that kind of covers if statements. And another thing to keep in mind, however, is that we can't nest if statements. They can
Right.
be infinitely nested, basically.
But before you get into nesting if statements, there's a couple of things that we can point out. One is that our blocking curly braces over here, if we have only a single line of code that's going to be executed
Right.
if something is true, these guys are not necessary.
Not
if
necessary at all.
If you could, real quick, Joel, go ahead and remove
Right.
those just to help demonstrate that purpose. Because if you guys out there watching these videos go and take a look at someone else's code,
It
I just-
often looks like this.
Exactly.
So if we run this, compile it, it's perfectly fine. If we run it,
Everything's still exactly the
perfect.
same. The reason that you usually bring in your blocking braces is if you start having multiple lines of code that need to be executed if, let's say, the condition evaluated to true or if it evaluated to false.
Right.
So that's really important to understand. And where you put those braces, as long as the code is inside it and they start after your if, then everything's cool. And I say that because this is another very common way that you'll see things right here as I kind of reach across right after the if, starting over here and then ending wherever it's going to end
right,
at.
say, in this case, right there.
Exactly. Or even sometimes you may see stuff that looks very similar to this as well. I'm just pointing out different styles in which
Right.
you may see things if you look through other people's code online.
Just so you don't freak out when you see another
Right.
style.
Now we're going to try to keep ours relatively structured where we're always going to start and end our curly braces on new lines by themselves just because it makes things real easy to quickly see the blocks and where they belong to. Not saying that this is a bad approach at all. This is a very common approach right here. But again, this is just the way we like to present information so that everybody that's learning this all together can quickly identify things.
Right.
So let's see. There seems like there was one more thing that I wanted to point out. Yes, there is. And that is Joel, if we could do this, if I could get you to delete out all of that and then change this to see out something like shows no matter what. Because this is really important to understand for the beginners out there. And that is, when we come in here, as a matter of fact, let's go ahead and set that back up. There you go, so it looks easy to understand. There you go. So now I'm going to grab the mouse from poor old Joel over here and take a look at this. Basically what's going on right here is we're going to perform the check, and if it's true, we're going to do this. If it's not true, or if it's true, it doesn't matter. We're going to still continue right here with execution inside our function.
Right.
That's very important to understand. So this guy is going to be output no matter what.
Right.
Okay, so right now if we were to actually execute this, the only thing we're going to see is shows no matter what because our statement evaluated to false, so we did not hit that true area.
Right.
Does that make sense?
Yes, it does.
Okay.
And plus, I mean, this is just one block.
That's right.
It's self-contained.
So that's very important to understand that.
Right. So I guess with that, we can show a little bit of nesting.
Sounds good.
So inside of here, if it gets inside this if statement, we know for a fact that x is definitely greater than 2.
Mm-hmm.
So we can say if x equals 3, and then we can see out x equals 3.
Mm-hmm.
And then we can end line on that. And what this means is it'll come in, it'll say, okay, is x greater than 2? If it is, then it must be some value greater than 2, obviously.
Right.
So it comes in here and says, if x equals to 3, print out x equals 3, and then this one is going to be executed no matter what.
As long as the first
as long as the first
is true.
condition is true.
That's right.
The second condition, x equals 3, does not have to be true for this statement to be executed.
Because it's going to be executed no matter what if the first if condition is indeed true.
Right.
That really brings us back to the whole idea of, remember, what's going to happen with an if statement is it's going to rather execute the one line that follows, or if they're inside curly braces, then it's going to execute the whole block.
Right.
That's really important to make sure you understand that.
So, I mean, let's run this just so you can see what's going on. And let's actually debug into it again just because it kind of
It's
makes
so
it
cool.
right. So we can go in here and we can see that x equals 3. 3 is greater than 2, so we go inside of here. And x does equal 3, so we go inside of this if statement,
Right.
this if block, if you will, and we'll print out x equals 3. So if you go down to our console here, then we can see x equals 3 is printed out. If we print that out as well, we also get statement is true.
Cool.
Followed by shows no matter what.
Cool.
So that kind of shows that. And the
And
next thing,
if you want to, well, I was just going to say drag on back up and change x to maybe 4, just so that you can see that no matter what the statement is true, it's still going to get printed because the first if is indeed true.
Right, so let's go into here, set x equal to 4. 4 is greater than 2, so we go inside of here, and 4 does not equal 3.
Right, so we
skip that guy, and we go straight to statement is true. And if you look here, nothing has been printed out so far.
That's correct.
So if we run this, you'll notice that now we have statement is true, and then it shows no matter what is printed out as well.
There you go. Very nice.
So let's stop debugging.
And can I throw one more thing at
Sure.
you in regards to the ifs real quick?
Yeah.
You showed the very cool logical operators earlier.
Yes, we did.
Can we mix those in here?
Very good point. We can go inside of here and say if x is greater than 2 and x equals 4. And then we can, just to make it more simple, we can delete all that out. And what this means is it's kind of a contradicting statement, if you will. Actually, to make this a little bit more logical, we can say and x is less than 4.
There you go. So now we're looking for a range.
Actually, we're looking for, a range.
Yeah.
But in this case, our range is so small that it's only one value, which is 3. So if we put that in, and you'll notice that, let's just go ahead and run this. So x equals 3. What this is saying is, notice our x value is 3 here. Is 3 greater than 2?
Yes.
Is 3 less than 4?
Yes.
So both of these statements have to be true, like we showed in the last lesson, for this to actually become all true.
That's right.
So if we run this, you'll notice statement is true.
That's correct.
So let's go through this and stop debugging. So now I guess with that we can show the switch statement.
Sounds good.
So let's go down here and let's type a switch.
Basically, now can I throw something out with this? I kind of like explaining the switch statement like this. It's another alternative for, determining if, like, something's... It's kind of like a true or false thing in a roundabout way. But here's the way I always like to think about it. Think about a Coke machine that you walk up to, and you can dump coins in there. And it's going to take these coins and it accepts them, but it's going to route them appropriately based on the type of coin it is, or the amount, if you will.
Right.
So here with a switch, if you're dealing with a type of setup where you're looking for a routing kind of ability. Like if it's one value, we want to do this section. If it's another value, we're going to do this section. Or if it's another value, we can do this section. Or another, we can do this. Or if it's none of those, by default, let's just spit whatever you stuck in back out.
Right.
Then you may be interested in using a switch. You can definitely set this up with an if statement.
Right.
But you may end up with so many embedded ifs.
Right, this would probably be shorter.
Yeah, it would not only that, but this becomes kind of a little bit more tedious to manage.
Right.
Especially if you're dealing with a lot of different things. So with that...
Okay.
Sorry.
Nah, it's all good.
I'll go back to being the student now.
So let's go into our switch, and what it's looking for in this parentheses here is the number that's going to direct where we're going to go. The number evaluation.
That's your money.
Yes, that's my money.
Switches.
So we can put a variable. Exactly, the Coke machine. We can put in a variable or a number either way, just as we can up here.
Okay.
And we can say switch x, and what you do inside of here is say case 1 or whatever. We can say case 1. So if x is equal to 1,
then
we're going to do
a quarter.
the following. Then it's a quarter, let's say. So we can say cout. It's a quarter.
Hey, all right, he's making a Coke machine for me.
I know, it's so cool. Now, this is kind of interesting. Right now, well, let's put in another case statement just to make this more clear.
Right.
We'll put in a case 2. We press enter, and now if we see out, what do you want to see out? What do you want to?
It's a dime.
It's a dime. How creative.
Because the great thing is, for anybody who puts in a quarter right now, they're going to have 35 cents automatically credited. Isn't that cool?
It is cool.
People are going, what are you talking about?
So basically what's going to happen here, well, actually, let's show it, because that's always cool. So let's go into here, and let's go ahead and let's go up to here.
So it should only print out what you have. So right now, by looking at it, you would think by default, well...
It's going to print a quarter.
It's going to print a quarter.
And that's it.
But I'd say the Coke machine's been designed slightly incorrectly so that you're going to actually get 35 cents if you stick a quarter in. And here we go. Let's find out.
So let's step into here. And you'll notice that x, we initialize it to 1. We're going to skip over that. Now we switch into our switch statement.
Right.
And look, it does recognize that it is 1.
Picked up the quarter. Woohoo.
So it's a quarter.
So let's check out the console.
It's a quarter.
Hey.
Very cool. But, It printed out it's a dime.
He went real quick. The yellow arrow, as you guys may have noticed, it did jump down into the it's a dime section, too.
So it jumped into both.
So 25 plus 10 gives you 35, and suddenly your drink is free.
Yes, it is.
Okay, what's happening here is the way the switch statements work. Basically, once you fall into a case, if you don't break out of the statements that you're going to be executed once you get into the case,
Right.
it will fall through to the next case and the next case until you hit a break or we get to the end.
Right. So you can specify ranges with that technique, which is kind of
Which
cool.
is very cool.
Very
It's very
cool.
powerful because then you can, if you have something that hits and you need to pick up several things,
Right.
then you can easily do that with a switch statement. Now you're really making things more difficult if you wanted to set that up with
Right.
a series of if statements.
Much more difficult. So if we go into stop debugging, let's go ahead and add the break statement. So all you need to do to add a break is type break,
Yeah,
semicolon.
the Coke company got tired of all of their products being taken away, and there's just not enough money there.
That's right.
So they realized there was a flaw in their program.
So if we run this, it does run fine without the break on the bottom here, because after it gets to here, well, let's run this. Let's go into here. Let's actually add another breakpoint. Let's press F5, run this to here, and let's step through this. Gets to our switch, says it is a quarter. We break out of it. You'll notice that all we have is a quarter.
There you go.
So it works perfectly fine. Now, there may be cases where you want maybe 2 or 3 things handled, 2 or 3 numbers,
Mhm.
but then you want to have a default case as well.
Mhm.
So what we can do is go into here and type default. So now, if it's not 1 or it's not 2, it's going to go to default.
Right.
So,
This is where you'll see out, spit it out.
Right.
Not money.
So we need another break statement here, obviously.
That's right.
A break, yeah.
Otherwise, it's going to take your dime and spit it out.
Right. So if we go into here and we can say, actually, what am I doing? We can go into here and let's just press F5 to get inside of here and go into here. Now it says it's a quarter, so it's all good, and now it jumps all the way back to
Right.
the bottom. What if? Let's just kind of stretch him up
You
just a
happen to
little
put
bit.
some funky 60-cent piece in there that you found somewhere.
Right. So let's go into here and let's change this to something like 3, which won't be handled by any of these, right?
Right.
So let's go into here and let's jump through this. You'll notice that it jumps automatically to the last one here where it says spit it out.
That's right. Hey.
Very cool.
Watch this.
So now if I press F10, it
Okay.
jumps to the next one.
Okay. You know what?
What?
You up for a challenge?
Sure.
Live?
Yeah.
Let's try a Coke machine.
Try a Coke machine. Cool.
Because we can use variables to keep track of how much money you have.
Right.
Let's make a program live. I know.
All right.
Let's do it.
All right. So let's see. What do we need to do? Basically, we'll want a value that stores how much money we have.
That sounds good.
So we can say money. And we can say we start out with 0 money.
Okay.
And we need to basically, how do you want to handle this? Pump in
Have
different
another
values?
variable that's just called user, and
Okay.
that user is putting in money.
So we can say user equals.
And we can start out by, let's see, what is a good way to do this? Tricky.
Yeah, it's tricky.
Because we only get one shot through it at the moment.
Right.
Yeah.
We
Okay, that's
could do
okay.
this.
Let's do a one shot. Let's go ahead and pretend that they've already put 10 cents in.
Right.
So we can go ahead and set money to, say, 10.
Right. And
And
we
then
can say
the user's putting
to,
a quarter in.
Right, so
and-
we can say a quarter is equal to 1.
Okay, that sounds good to me.
So we can go down here. Let's just get rid of our if statement for now. And inside of our switch, we want to switch based on the user.
That's right.
And inside of our case, if the case is 1, it's a quarter, so we want to add 25 to that.
That's right.
So we can say money plus equals 25.
See, look at that. See, now we're getting to use some of the things we learned in the other lessons.
Right.
So we're taking money and we're adding 25 to it.
Money,
So which is 10 plus 25,
which is 35.
35.
And we can go into our case 2, and let's just say this is a 10 cents or
Okay,
a dime.
A dime.
And we can say plus equal 10 and
Okay.
end it with a semicolon.
And default will spit it out.
And default will just spit it out and not give
And
us
now
anything.
we can do an if down there that says if it's 35 cents.
Money is equal 35 cents.
Okay.
Then we can print out you've got a Coke.
Sounds good.
Else we can say you.
Now, of course, the you have nothing would be pretty sad if we went in there and actually dumped in 2 quarters so
yes,
that we
they
had
would be
50.
kind of angry.
Yeah, be like, where's my Coke? I want my Coke.
Right.
I want my Coke. So anyways, what we need to do is, what about some change?
Well, we can also do change. We can say, we can set up in here, if money is greater than 35, we can say, we can set that off as an if.
Okay.
And we can say, see out, well, let's do this. You have, and then we can say, set this off,
Okay.
and have another statement being executed.
Right. So let's say Coke's 35 cents. So we need to.
You have money minus 35.
Right.
And then let's put this in parentheses just so it looks a little bit more
make
clean.
sure. Yeah, absolutely.
And we can set this off, and let's say end L.
Okay.
So you have 35 cents in change. How's that?
Okay.
So basically, that's all we need to do for that, and then we can say at the end.
Now, at this point, what we could do is right after that line, we could go ahead and subtract 35 cents away from, or you could go ahead and subtract the money, or 35 away from money.
Right.
Or hang on, let me find the other way. What I'm wanting to find is a way to think about it logically. Get into a condition where if it's 35, then you're only left with.
Well, you can just say money equals 35.
There you go. Look
and we can do that, and then we say you've got a Coke.
Now we fix the bottom else at the end as well, because if it's not 35,
put more money in.
Yeah, put more money in, because you definitely did not put enough in.
Right.
Ta-da! We made a Coke machine.
We made a Coke machine. How exciting! So let's stop debugging for a sec here, and let's go into here. Let's go ahead and continue debugging because it's kind of cool to see what's going on here. So we're inside of here. Our money is currently nothing, so we initialize that to 10, initialize user to 1, go into our switch, and money is now 10. We've just got into the first one, which is considered a quarter. Add 25 to that, so we get 35. Break out of that. It is money greater than or equal to, greater than 35. No, so we have no change. So we don't go into that if statement.
Which is good.
And then we can say, is money equal to 35? Yes, it is. So we can go in here and say, you've got to
go. Tink, there goes my Coke.
And we don't go into the else. If we go into here, you say, you've got a Coke.
Sweet. Now
Very cool.
Now we're big spenders.
Yes, we are.
We want to put in, we need to, actually, we don't really have it set up at the moment to handle big spending of money.
We don't.
Let's go ahead and say, we do in a sense. Let's go ahead and go back up to money, and let's pretend that we put a quarter in already. So
we've already put a quarter in.
Now we're big spenders. We're going to drop 2 quarters in.
So let's go back into debugging just because it's kind of nice to see how it's running. And initialize the first 2 variables, go through our switch, add 25 to our money, and that'll give us 50.
That's right.
And
big
break
spenders
out of that.
we are.
Yes, we are.
Now, is money greater than 20 or 35? Well,
yes, it is.
Yeah, because we're big spenders, of course.
And it says you have, and it'll say if we go down here, you have 15 cents in change.
Woohoo!
And then we change money equal to 35, and then I'll say, is money equal to 35? Yes, it is. So we say you've got a Coke. And out of that, look in here, you've got a Coke.
We got 15 cents in change bag. Man, think of the things we're going to be able to do this weekend.
Ooh.
And we got a Coke.
Isn't that nice?
So there you guys go. Something a little bit better than Hello World.
Yeah, that's for sure.
That's for all of our fans out there in the class. And you know who you are. And so anyways, here is
so that's basically
something a little more interesting.
Right, definitely. So let's go ahead and, well, basically that covers switch statements. The last thing I want to say is kind of show is the go-to.
Okay.
Now, this is not widely used as much anymore because of classes and everything inside of C++.
Sure.
But it's still useful to know. It can come in handy every now and then.
Absolutely.
So let's go down here and let's just do something very simple. Let's say go to this place. Okay, this place is just a name of a place that we want to go to. All we need to do is say this place and then end that in a colon. And what that's doing is saying, this statement says, I want to go to this place, which is a location that I've named, okay? And then this is the location I named. All you need to do to create a location to go to is by specifying the name, followed by a colon, and that's it. So let's say, let's cut this out and say, let's go to here. What will this do?
What's going to jump us back up there?
It's going to jump us back up here, and then it's going to create an infinite loop, isn't it?
Got it.
So let's just say...
then you're going to end up kicking the Coke machine.
Right, which would be kind of bad. So let's compile that, and let's just kind of put a breakpoint in here. Let's press F5, and yes, we want to build. And let's step through this as we did before, just really quick. And is our money greater than 35? Yes, you have this much change. Yes, yes, yes. And is money greater than or equal? Yes, so we've got a Coke. So we've printed this out. You have 15 cents in change. You've got a Coke. Now we end this, and now we have this statement that says go to this place.
That's right.
So it's going to want to go to this line 28, which says this place. So it's going to go to here, and now it's going to start back up here again, and it's going to do the same thing again. Print, you've got a Coke.
Sweet. So suddenly,
you've got a million Cokes.
I got my 15 cents, and it just keeps kicking
it's
out Cokes.
It's a functioning Coke machine.
Sweet.
So basically, that's it. I mean, it's kind of useful just to see that you can do this. I mean, it can come in handy every now and then, so it's kind of good to know.
in regards to the go-to
Right.
statement. But ifs, they're very handy. You're going to be using ifs and switches all over the place. All right, very cool. Well, that's going to pretty much wrap up this lesson right here on control statements. If you feel a little uneasy about it, don't worry. You can rewatch the video, or you're going to find that we're going to start using if statements in all of the other lessons, and you will quickly become comfortable with them. So that's going to wrap this lesson up. Thanks.